Koyo. Well, that's the way we say hello in Benin. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of physics. Now, children, are you feeling scared looking at this pic? I'm sure you are, but don't do so, as this is rather the sacred Temple des Pythons of Oida, Benin. It is here that the wooden religious practitioners keep the python as a totem. Here you will be so charmed that, like a snake charmer, you're going to keep these friendly pythons around your neck, and I'm sure you'll take a pic and put it in your Instagram handle. Do so. And when you do so, make sure, going to Benin, you have to make sure that you have the great Beninese food, which is yowo doko, and also to tell all the people of Benin that you get to meet Koyo. In this note, children, I'm going to start off this lecture of current electricity, where today we are again going to pursue the same topic that we did earlier, that is, a difference in potential causes a current to flow. Now, children, if suppose there are two conductors which are put in touch, then you know that there will be a passage of electric current, right? And this passage of electric current is momentary. The more scientific word is it will happen for an infinitesimally small period of time. Now, that won't help us, because if suppose we want electricity, we want light for a prolonged period of time. We don't want to have it just for a split of a second, right? And that is the reason why there are different mechanisms with the help of which we can have electric current, or rather electricity, right, for a prolonged period of time. For that matter, whenever we talk about electricity, it is actually electric current which comes for a long, or rather a prolonged period of time, which can then be used for different beneficial purposes. Now, there are different ways by means of which we can do this. One of the ways is using an electrochemical cell, which now we'll be studying in detail. Another way is if we keep a moving coil in a strong magnetic field, even then we can have a flow of electrons, because a difference of potential which is created. Next, if we talk about a thermocouple, then we also create a potential difference by keeping two different metals at some distance, right? And both of them being kept at different temperatures. Similarly, if say we talk about a solar cell, even then we talk about transforming the solar energy to electrical energy. All of these use a difference in potential, due to which there is, over a prolonged period of time, some electrons which is made to flow, and that helps us in bringing up electricity, which can be used for different useful purposes. Now, children, here at this time we are going to discuss a electrochemical cell. So what is a electrochemical cell? Remember, children, that electrochemical cells are of two types. The first is a primary cell, and the second is a secondary cell. Now, a primary cell is that in which, when we use chemical reactions to be converted to electrical energy, they are irreversible. That means once the chemical reaction is done, it cannot be brought back to its original state. However, contrary to this, we also have secondary cells, which are also known as accumulators or storage cells, where the chemical reaction is such that it is reversible. That means once a chemical reaction is done, then it can be brought back to its original state, right, by bringing in some chemicals again in the cell, right? So we have two types of electrochemical cells. The first is the primary cells, where the reactions are irreversible, and the second are the accumulators or the storage cells or the secondary cells, where the reaction can again be brought back to the original position where the reaction just didn't start, right? So these are the two different types of cells. Here at this time we'll be discussing primary cells, and in order to discuss what primary and secondary cells are of the different types, I will be keeping a complete lecture so that we can have a very good idea about the different type of cells. Now children, when we talk about primary cells, remember we primarily talk about three types of primary cells. The first is we talk about a simple Voltaic cell. Remember last turn we talked about Alessandro Volta, Italian physicist who brought up the concept of potential difference. He also developed the simple Voltaic cell, which at this time we are going to discuss. Except a simple Voltaic cell, we also have a Daniell cell and we also have a Leclanche cell, which are all examples of primary electrochemical cells. Now what happens in a simple Voltaic cell is that we have two electrodes. Remember, these electrodes are pieces of metals, right? Normally they are cylindrical or they can even be cuboids, right? Now when we talk about these electrodes, as they are metallic, so obviously when they are put in ionic solution, then they have a habit of becoming electropositive. That means they have excess of electrons, right? Metals normally have excess of electrons, and these extra free electrons are on the surface, and these electrons, when they get into ionic solution, that is of an ionic compound, like say we talk about sulfuric acid, or say we talk about hydrochloric acid, we can even talk about sodium chloride or any other such ionic salt or ionic say acid, right, which can break up into ions, right, and then when further put in aqueous solution, they can further break up into ions, where water also breaks up into H ions and OH minus ions, that is the hydroxyl ions. So when these electrodes, which are the pieces of metal, they are kept in a electrolyte, which is the ionic liquid, then what happens is both of these have a tendency of giving off these electrons to the ionic liquid. But one that has a habit, or one that has a state of giving off more electrons, becomes more electropositive, right? Because when it gives off more electrons, then it will develop a greater deficiency of electrons, and as such there will be a positive electrode which will be created, right? Because deficiency of electrons causes the positive ions to be in excess, and then that electrode will then become the anode, right, or the positive electrode, and that electrode which has a lesser habit of giving off the electrons in the ionic liquid, or in other words you can say that which is less electropositive, right, will then become the cathode. Okay, so one fact that I had told you about both of these electrodes is both of these electrodes are electropositive. That means they have a habit of giving off electrons in an ionic liquid. The one which has a greater habit will become more positive. As such, it will become the positive electrode or the anode, and the other will become the negative electrode or the cathode. Now children, what happens is, like in this case, if we talk about this electrode, right, it is say the copper electrode, right? This is one of the metals which has been chosen for this cell, which is known as the simple cell or the simple Voltaic cell, and the second is the zinc electrode, right? The copper electrode, children, is the positive electrode, and if we talk about the zinc electrode is the negative electrode, right? Now here copper, when it goes into this electrolyte, it goes as Cu++, right? And zinc, when it goes into this ionic solution, it goes as Zn++, right? So this is what you require to remember. And then further, if we talk about this electrolyte is actually sulfuric acid. So this sulfuric acid breaks up into H ions and also into sulfate ions. So H ions are the positive ions and sulfate ions will be the negative ions, like SO4-, right? Now the positive ions, they will move towards the negative electrode or the cathode, and the negative ions, that is the anions, they will move towards the anode. That is, they have a movement towards opposite directions, towards oppositely charged electrodes, right? As opposite charges attract each other. So this is what is going to happen within the electrolyte. That is, the negative charges, that is the anions, they will move towards the anode, and the positive charged ions, that is the cations, they will move towards the cathode. In this movement in opposite direction, right, there is a resistance which is created, and as it is within the electrolyte, it is known as internal resistance, as it is internal to the circuit. Now, what is the external circuit? When we have these electrodes, right, which are at positive and negative potentials, they've been connected from outside, from the external circuit. In the external circuit, there are devices like the galvanometer, voltmeter, ammeter, say a bulb, a fan, a rheostat, or other such electrical devices are attached, right, which will show a movement in accordance with the electrons that they receive. So if there is a fan, the electrical energy will be converted to mechanical energy when the electrons start moving from the cathode to the anode. Remember, the direction of flow of the conventional current is from the positive electrode to the negative electrode, and the direction of flow of the electronic current is from the cathode, that is the negative electrode, to the positive electrode. However, we always consider the direction of flow opposite to the direction of flow of electrons, that is the conventional current's direction, to be the actual current's flow. Now children, in the external circuit, this is how the movement of electric current happens, and in the internal circuit, it is actually in both the directions, the anions moving towards the anode and the cations moving towards the cathode, right? Now, when such a sort of a thing happens, then when we talk about both of these electrodes over a period of time maintain this potential difference. That means one remains to be positive and the other remains to be negative, due to which, that is, due to the potential difference, there is always a passage of electrons which happens, right? And this, children, is done by means of this chemical reaction, which is also a stable reaction, which doesn't happen too very quickly. And that is the reason why this reaction being steady, the current that you receive is also a steady current. So when you talk about an electrochemical cell, it is actually one such where the chemical energy is changed to electrical energy. When the chemical reaction is steady, then the flow of electrons is also steady. However, as here we are talking about primary cells, so gradually as the reaction processes, so the chemicals start dying down, and as the reactions are irreversible, so they happen in one direction and then they cannot be brought back to the old direction, right? So this is how, children, we have the functioning of an electrochemical cell. And in an electrochemical cell, thus what happens is we have thus the passage of electrons from the cathode to the anode in the external circuit, and in the internal circuit the cations and the anions both move, right? In the next lecture, we'll be discussing about the electromotive force. We'll also be discussing about the terminal voltage. We'll be discussing about the voltage drop and how these terms are related among each other. And further, we'll also be discussing the different formulae of each of these, right? So that your numerical basis along with these concepts is also very clear, so that when numericals come your way, you're able to do it really well. So I'm sure all of this that we discussed here in this lecture is perfectly clear. Yes? Aman? Virendra? Everybody clear? Monica? Very good. So that's all for now, children. Next time we'll meet and we'll study more. So we'll be talking about these topics. Then we'll talk about the two different resistances. And then further, we'll move on to numericals. Bye, children. Have a nice time. Bye.